So for the complex number points, we have A, B, C, D, and E. So the real component, or all of the coordinates, are going to be in the form A plus BI, where A comes from the real component and B comes from the imaginary. So the coordinate for A, since it's to the left, 1, 2, 3, 4, that's negative 4 plus 0i. So you could just write negative 4. For B, that's up 1, 2, 3, 4. So that's 0 plus 4i. Or you could write 4i. Now for C, it has both imaginary and a real component. So we're going to count 1, 2, 3, 4, 5. So that's to the right 5 and up 1 in the imaginary. D is to the right 4 and then down 3. And then E is to the left 2 and down 1. Okay, so for real, pure imaginary, and or complex, all three numbers here are complex. Every number is a complex number. The square root of 3 is real. The square root of negative 9 is pure imaginary. And 5 plus 2i is just complex. It's part imaginary and part real. When we do operations with I, it acts like a variable. So we're going to combine like terms in 37. I'm going to take 3 plus 5 and get 8, and then 2 minus 7, so that's negative 5i. When we multiply, you can FOIL, box method, distribute, whatever your preference for multiplication. But I squared equals negative 1. So this term becomes plus 6. So our final answer is 6 plus 5 for 11 minus 11i. Now 39, those two numbers that we're going to multiply are complex conjugates. They're conjugates because the signs in the middle are opposite. So when we multiply, because they're conjugates, 16i and negative 16i add to 0. This term becomes plus 4, so our answer is 68. When you have a binomial term squared, or this complex number squared, that means it's the number times itself. I always recommend writing it out as one term times itself, so you're not tempted to distribute the power, because now we're going to multiply and then I squared equals negative 1, so this term's negative 49. So negative 49 plus 4 is negative 45 minus 28i. Now for 41, we can't have I in the denominator because I is the square root of negative 1. So if we multiply the numerator and denominator by the complex conjugate, and the reason you have to multiply both numerator and denominator is because when you have anything divided by itself, that's a value of 1. Well, anything times 1 is still that same value. So we're not changing the value of this equation, we're just going to change the way it looks. So in the denominator, we've got 4. Because they're conjugates, the middle I terms are going to cancel out. When I multiply 2 times I and negative I times 2, that adds to 0. So then the last piece is going to be minus I squared. And then in the numerator, we're going to multiply 7i times 2 and 7i times I. Now we have to simplify. I squareds are -1. So the denominator is 5, and the numerator is -7 plus 14i. Now to write a complex number in standard form, it needs to be a plus bi. So I'm going to take this fraction and make it clear what a and b are for my final answer. Now we're going to multiply by the complex conjugate for 42. That's 1 minus 6i. So when I multiply, I'm going to do that work up here at the top. The numerator and then the denominator, because they're conjugates, I can skip the middle terms. Any I squared is -1. So now combining our like terms, in the denominator that's 37, in the numerator 42 plus 2 is 44, minus 5i, but then to write that in standard form, I'm going to make it 44 37ths minus 5 37ths I. So now 43 and 44, they're asking for the distance from 0. Absolute value means the distance from the origin, or the distance to 0. So if we plotted that number, it would be 2 to the right and 3 down. So we can use Pythagorean theorem to calculate the distance. So the value for 43 is the square root of 13. Same thing for 44. And when we simplify that, that's 169, and the square root of 169 is 13. To complete the square, we take half of b and square it. So that's -3 squared, which is 9. And then for 46, 11 over 2 squared, that's 121 divided by 4. So that's the number that would go in the blank there. For discriminants, that is the value underneath the square root in the quadratic formula. So I'm going to use D for short to abbreviate discriminant. So if the discriminant is greater than 0, that means there's 2 real solutions, or 2 real roots, 2 real x-intercepts. If the discriminant equals 0, there is 1 real root. And if the discriminant is less than 0, meaning it's negative, there's 2 imaginary roots, and none are real. So to solve 48, my first thing I would want to check to see is, does it factor? Nothing multiplies to 11 that adds to 3, so it doesn't factor. I could complete the square, but since b is odd, I really don't prefer to complete the square, so I'm going to use quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. If you look at the very first page of your exam review packet, it says no formulas will be provided for you on your exam. Therefore, this is one that you will have to have memorized. So the two answers for 48 are 3 plus root 5 divided by 2 and 3 minus root 5 divided by 2. And now for 49, I'm going to check to see if it factors. So I have to potentially split the middle. So 3 times 2 is 6. So what multiplies to positive 6 that adds to positive 1? Nothing. If it was a combination of negatives, then it would potentially factor. But this is not going to factor. So instead, I'm not going to complete the square because a is not 1. So let's do quadratic formula again. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So when I simplify this, I know the discriminant's negative. So I'm going to have imaginary answers. We don't leave the negative underneath the radical. We're going to rewrite that as negative 1 plus or minus I root 23 all divided by 6.